Algebra 1, ciao. Sorry about that. That would be hello in Italian. All right, lesson 7, creating and solving quadratic equations in one variable. That means we're doing more word problems. I hope you didn't groan, because word problems are sort of the bread and butter of algebra and thinking deeper and yeah. So let's just begin. Opening exercise. The length of a rectangle is 5 inches more than twice a number. So 5 inches more than twice a number. I just took those words and made it into an equation, right? All right, the width is 4 inches less than the same number. We actually have to write that one backwards, though. The subtraction's very different, so 4 inches less than the same number. So let's go ahead and write this one in the right order. 5 inches more than twice a number. So I've got a rectangle. I have length and width. The perimeter of the rectangle is 44 inches. 2 times length plus 2 times width equals 44 inches, because perimeter is the distance around a rectangle. Sketch a diagram of this situation, check, and find the unknown number. Well, we can do that because I know what perimeter is. So I can do 2 times the length plus 2 times the width equals 44. Let's go ahead and distribute. 4n plus 10 plus 2n minus 8 equals 44. Collect like terms. 6n plus 2 equals 44. Subtract 2 from both sides. I get 6n equals 42. Divide both sides by 6, and n equals 7. Unknown number is now known. So that was a fantastic problem, and we knew what the perimeter was. But what if we didn't know the perimeter, we knew the area? Well, that is our next example. So now we have the length of a rectangle is 5 more than twice a number, and the width is 4 inches less than a number. If the area of the rectangle is 15 inches squared, find the unknown number. So I'm going to draw another diagram. 2n plus 5, n minus 4, and the area, well, let's do this. Let's see, length times width equals area. So 2n plus 5, n minus 4 equals 15. Well, we had problems like this in the last lesson, and we were fine. Now we've put it into a word problem, and it gets just a little bit scarier. But not to worry, we learned how to solve this last lesson. I know, I'm just going to FOIL this thing. First, outer, inner, last. Get all the numbers to one side of the equal sign, and then solve it. Okay? So first, 2n squared, outer, minus 8n, inner, plus 5n, and last, minus 20 equals 15. Collect like terms. 2n squared minus 3n minus 20 equals 15. Subtract 15 from both sides. Continue the problem over here. I have 2n squared minus 3n. I have a negative 20 and a negative 15 is a negative 35 equals 0. Now I need to factor it. Okay, what is a times c? Negative 70. I need 2 things that multiply to 70 and add to negative 3. No clue. So let's just go for it. 2 times 35 doesn't work. 3 doesn't go in there. I have 5 times 14. That doesn't help. Still doing some math. Divide by there. That's actually not bad. I should have totally seen that. You can tell I'm tired, right? 7 times 10 is 70. I need -3, so I'm going to do that. So 2n squared plus 7n minus 10n minus 35. Need to get that out of there. Okay, factor by grouping. I can factor an n out of that. I'm left with 2n plus 7. And let's see, I think just a -5. 2n plus 7. Yay! Okay, these factor out to here. 2n plus 7, n minus 5 equals 0. Take each binomial and solve for your unknown. 2n plus 7 equals 0. 2n equals -7. N equals -7 halves. N minus 5 equals 0. Plus 5 to both sides. N equals 5. Now, again, what are we looking for? I don't even remember. It says right here, find the unknown number, because we need that number. Well, can I have a negative measurement? If I plug that in, I'm going to get a negative answer for my length and width. So that one does not matter. That right there is my unknown number, because it's actually possible. It makes sense, right? Another way to relate expressions to the area, we have another area problem, is to look at it from proportions. And here's your example to look at area with proportions. These are a tad bit more complicated, but no biggie, right? A picture has a height that is 4/3 its width. I just wrote down what it said. It is to be enlarged, so the ratio of height to width remains the same, but the area is 192 inches squared. What are the dimensions of the enlargement? All right, so area equals height times width. Same as length times width. We're just using height. We're not sure about this, but I know if I make one of these an x, I can use this ratio to figure out what's going on. So let's let 4x, I can't read that, sorry. 4x to 3x represent the ratio of the height to width. Cool. Now we can go ahead and use our equation. Area equals length times width, or sorry, height times width. 4x times 3x, and we know that area is 192. Let's go ahead and do some multiplication. 4 times 3 is 12x squared. Divide both sides by 12. 92 divided by 12 is 16. Square to both sides. Plus or minus 4. Let me write that different. Sorry. 4 or -4. Okay, we're talking about actual measurements here. So is -4 even a possibility? No. x equals 4 is our only possibility. Therefore, we know that height equals 16 and width equals 12 because height is 4/3 of the width. There's our final answer. All right, now we just have a bunch of exercises. Let's see, there are 5 of them, 6 of them. I think 6 is a challenge, but 5 of them, okay? I'm going to do a few of them, and then I'm going to work a few and have you work them out yourselves and check your answers with what I do. And those may be on a future assessment, so I would definitely not just skip all of these and not listen to the end because they are a big deal, okay? All right. The length of a rectangle is 3 centimeters more than 3 times its width. Oh, so many things. 4 centimeters more than 3 times its width. See how I just changed those words into symbols? So we know that the length is that, and the width is W, because I'm cool like that. If the area of the rectangle is 15, let's do this, length times width equals 15 centimeters squared, find the width. No problem. Let's go ahead and do some multiplication. I'm going to distribute this backwards. And I get 4w plus 3w squared equals 15. Well, this is just a quadratic equation. I know how to solve quadratic equations because I've been doing it. Go ahead and put it in the right order. I made a mistake. You didn't catch it, I did. Okay, I can't reduce it, so I need to do a times c is 45. And that has to add to 4. 5 times 9. Oh, no, that doesn't work. Ooh, I did make a mistake. I caught it though. That's negative. So that's negative. So we're good. Haha, I caught all my mistakes so far. Go ahead and work this out to factor by grouping. Okay, group the first 2 and the last 2. I can take a W out of here and 3 out of here. That gives me 3w minus 5 and w plus 3. If I'm solving for w, that first binomial, 3w minus 5 equals 0. Add 5 to both sides. 3w equals 5. W equals 5/3. And the other one, I've got w plus 3 equals 0, w equals -3, which we all know is not possible. This right here is my only answer. That's my width, 5/3. The ratio, here's a proportion one, the ratio of length to width of a rectangle is 2 to 3. Find the length of the rectangle when the area is 150. So I can do 2x length and width is 150. Go ahead and multiply that out and divide both sides by 6. Square to both sides, I have x equals 5 or -5. Yep, that one doesn't matter. So when we're finding the length, we're going to do 2 times 5 is in fact 10 inches. we have length to width is 2 to 3. So the length is 2x, the width is 3x. That's how we know that. Okay, this is the last one I'm going to do as I record. The rest of them I'm going to do and then just show you the answer. Okay, so here we go. One base of a trapezoid is 4 inches more than twice the length of the second base. So one base of a trapezoid is 4 inches more than twice the length of the second base. I'm actually going to make this the second base. Okay, let's rewind a little bit. Area of a trapezoid is 1/2 base 1 plus base 2 times height. Okay, base 1 plus base 2 times height. So base 1 is 2 times base 2 plus 4. Cool? Okay, let's read the rest of it. The height of the trapezoid is 2 inches less than the second base. So height is base 2 minus 2. All right, so we know base 1 is 2 times base 2 plus 4. Height is base 2 minus 2. The area is 4 inches squared. So let's go ahead and replace everything. Substitute. I've got 1/2. Base 1 is 2 base 2. I'm just substituting. Plus 4 plus base 2 times h. I just substituted base 1 for that and h for that. And that is equal to 4. All right, let's do some simplification. I'm going to go ahead and get rid of that 1/2. I think I'm going to multiply both sides by 2. That seems to be the best thing for me to do. Okay, so collect like terms. Base 2 plus base 2 is 3. Base 2 plus 4. Base 2 minus 2 equals 8. Go ahead and FOIL. 3 base 2 squared minus 6 base 2 plus 4 base 2 minus 8 equals 8. Subtract 8 from both sides. I've run out of room. Go ahead and write this down. I'm going to get a new slide. Okay, that's the last thing I did there. So let's go ahead and collect all our like terms. I have negative 16. This right here gives me negative 2b2. And that's 3b2 squared. Can't simplify. Bummer. So a times c is negative, let's see, 8, 3, 4. Negative 48. What multiplies that to give me a negative 2? Let's see. 3 times 16 doesn't work. 4 times 12. 5, 6 times 8. There we go. I need a negative 8 and a positive 6. That gives me a negative 2. Go ahead and factor by grouping. Plus 6b minus 8b minus 16. First two terms, second two terms. I can take out a 3b, 2. I'm left with a b2 plus 2. That should be a 2. I'm going to take out a negative 8. I'm left with b2 minus 2. Okay, oh, plus 2. Haha, I caught it. These factor out. b2 plus 2 times 3b2 minus 8. Go ahead and solve. Oh, equals 0. I keep catching these. There we go. So b2 plus 2 equals 0. Subtract 2 from both sides. b2 equals negative 2. We all know what we're going to do with that. 3b2 minus 8 equals 0. 3b2 equals 8. b2 equals 8/3. So right here, this is the measurement of base 2. Can't get a negative measurement, but my original one is 8/3. So I need to go back to the original problem and see what it's asking for. Find the dimensions of the trapezoid. Okay, I've run out of space. I'm going to change colors to see if it can help. I assume you've copied all this down. So the first base is, I went back to the first slide of this problem and rewrote everything that we knew. Base 1 was twice base 2 plus 4, and height was base 2 minus 2. So let's go ahead and substitute in. I know base 2 is 8/3 because we just solved for it. 2 times 8/3 plus 4 actually gives me 28/3. Go ahead and measure that one out. And then the height. Go ahead and substitute 8/3 minus 2. You can use your handy dandy calculator. It's 2/3 of an inch. So we have all of our measurements, base 2, base 1, and our height. Okay, I've got a few more. I'm going to work them offline and let you see the answer. You should go ahead and try to work them too, because you're going to see these on an assessment possibly. So they are a big deal. I just don't want to make the video any longer just by you listening to me talk. Cool? All right, I'll be right back. All right, there you go. Take a second, look it over, see what you think. Push pause, look at it again. All right, Karen wants to plant a garden and surround it with decorative stones. She has enough stones to enclose a rectangular garden with a perimeter of 68 feet, and she wants the garden to cover 240 feet squared. That's our area. That's our perimeter. What is the length and width of her garden? I do know that perimeter is twice the length plus twice the width, right? I know that twice the length plus twice the width equals 68. Let's see what we can do with that. This is sort of a mess, isn't it? I'm going to factor a 2 out. I don't know why. Maybe because I can. And divide both sides by 2. So length plus width equals 34. Ooh, I know. Perimeter equals 2 times length plus 2 times width. Area equals length times width. Let's go ahead and solve this for one of the variables and then use that and plug it into area. Okay? So I'm going to say length equals 34 minus W. I'm going to use that. So I've got area is 240, and that is length, which is 34 minus W, times width. Haha, one variable. I can do it. Go ahead and solve this. 34W minus W squared. I'm going to move this over to the other side by adding W squared to both sides. Subtract 34W from both sides, and 240 is already over there. I'm going to factor this. Hold on. Cool. 24 and 10. So minus 24 plus 10. Ooh. Actually, I'm wrong. I found it again. It's minus 10. So W equals 24 or 10. Okay? So both solutions are positive. Both can happen. Well, because the length and width are just sort of arbitrary distinctions, the garden's actually measuring 24 by 10, no matter what you assign length and width, right? So either quantity represents one of the values. Find two consecutive odd integers whose product is 99. We did these before, two consecutive. So if I say one of them is n, the other one is n plus 1. So if we're doing product, it's 99. Okay? N and n plus 1 is 99. You really need to remember those. Two consecutive, oh, no. Two consecutive odd integers. Dude. If the first one is n, the other one is going to be n plus 2. So let's solve it. N squared plus 2n equals 99. N squared plus 2n minus 99 equals 0. Oh. I think that's going to be 9 times 11. Like that? Yeah. So n plus 9, n minus 11. So n equals negative 9 and n equals 11, or n equals 11. Let's think about that. So if my first number is negative 9, the second number is going to be negative 9 plus 2, which is negative 7. That does not equal 99. Wait a minute. I'm wrong. If you thought you'd catch me, you didn't. That is a negative 9 and a positive 11, which makes this as a positive 9 and a negative 11. So if n equals 9, n plus 2 equals 11. 9 times 11 is in fact 99. But if n equals negative 11, n plus 2 equals negative 9, which also equals 99. They both work. Isn't that exciting? Both of the numbers work. Cool. All right, I'm going to go ahead and work this one. You guys are going to chill for a minute and then check out the answer, okay? There you go. That one's hard. We're actually going to learn about this in future lessons. I haven't taught you yet. Good job.